So in this particular episode, what we'll be covering is that correlation and regression analysis. Okay. So basically, what you might want to know as a student is that so if your probability of selection is, or if you get selected, or if you do good in your internal exam, you might want to pass your final exam, right? So there will be a bit of correlation between that. So based on that assumptions, you can basically find out what's your probability of passing the exam. Okay. So in case of for a businessman, why is correlation important for a businessman? They might want to know the expected profit upon the advertising spending, right? So there might be a positive correlation if there is within that. Normally it is, and then after that, what will happen is that the once you increase your advertising spending, your revenue will also go up, as will the profit as well, right? So you might want to know about that between that two variables, and then well, you could even use multiple variables, so it just depends. So right now I'm just discussing about two variables. So in case of correlation, how do we define it? So if you want to define correlation, so correlation is basically a statistical tool which is used to study the relationship between two or more than two variables. Not only two, more than two variables as well. Okay. So it is a statistical tool which is used to study the relationship between more than two variable or two variable. Okay, between two and more than two variables. Okay, so that will be very crucial. So what does this basically give us? So what does this actually mean is that so if one increases by, if something increases by one, then how much will the other thing increase by, right? That is your correlation. Okay, so suppose this is 1 2 and then this is 2 3. So see this is like this is increasing by 1, this is also increasing by 1, so the correlation will be 1. Okay, so there will be a perfect correlation. So correlation is also, you can tell it like it's a change in one variable is reciprocated by a corresponding increase in the variable directly or inversely. Okay, so I'll tell you about the inversely part a bit at the bottom. So if yes, then it is correlated. If no, then it is not correlated. So suppose if you say like, suppose this has changed from 1 to 2. So you could say like profit and yield. Okay, so let's say profit 1000. This is also 1000. Your advertising spending is 500. You have increased it by 50%, and then this profit has not changed. So that means it is not correlated. Okay. So any change in advertising spending won't change the corresponding increase in the other variable. Okay. So that could be in positive way or in negative way. Okay. So suppose, let's say, I'll give you another example. Okay, we can do it in this as well. So suppose if this has increased by 500, profit has decreased to 800 because your advertising spending has gone up by 50%, right? So your profit has decreased by basically 20%. So there is an inverse relation. So when one is moving in the other direction, the other is moving in the other direction. Okay, so that is inversely correlated. Okay, you could say that. So that will basically be negative. Okay. So if yes, it is correlated. If no, because in this case, there has been an inverse change, so it is correlated, but it is negatively correlated. Okay, that is very important term that you need to remember. And then the next thing is that if two variables move in same direction, just as I have said, so if this thing moves in same direction, and if the profit goes up by 1200, then this is positively correlated. Okay, so example could be your sales could go up as a result of advertising spending, or your height and weight. So as you increase your height, the weight might go up, or your yield and rainfall. You could predict that as well. So if your rainfall is higher for some crop, the yield might be higher. If for some crop the rainfall is higher, the yield might be less, so there might be negative correlation, but there could be some correlation, right? So in case of profit and investment for a businessman, it's the same thing. So if you make more investment, you might probably generate more income or profit, say, and then after that, so any increase in the other variable, if it results in a direct or corresponding increase in the other correlated variable, then that is positively correlated. Whereas if one is increasing, the other is decreasing, it is negatively correlated. So how many types of correlation are there? So it is normally simple correlation is there, and then partial correlation is there, and then multiple correlation is there. So we will look at simple correlation first of all. So when you're looking at the different types of correlation, so what we first look at is simple correlation. So what is simple correlation? Simple correlation is the correlation between, or if you are studying only two variables, okay, so it is a correlation or a study of variables between just two of them, okay. So it is a study of two variables. So that is known as simple correlation coefficients in layman language. So how is it denoted by? So it is denoted by R, and then it could be x on y or y on x, whatever that is, you use your denotation, okay? So you could use it as a y and on x, you could use it on a x on y as well. So you could basically twist your assumptions as you would like, okay? So basically examples could be like height and weight at different ages, profit and advertising different time period. You could look at that as well. Otherwise, you could look at price and demand of a quantity. A particular quantity might increase as the price decreases, so there will be a negative correlation between price and demand, right? So we will need to assess what kind of correlation they have. Whereas if there is no change, if one changes and there is no corresponding change in the other variable, then it is not correlated, okay? So a fare of bus and then diesel price at different times. So this could also be a factor where you can basically predict, suppose the prices of oil is going to increase, you might assume that you will be paying more for your public vehicles, right? So your budgeting might be changed because of that, right? So what are the methods that you could use? So there is different ways of finding out how much correlation is there. So what you could do is, first is you could use scatter diagram, which is basically you plot x and y in a graph. Okay. So what you do is you basically plot your figures, and then if they are in a perfect line, okay. So see how is it straight? So that means they are perfectly positively correlated, okay. So in this case, if it is going downwards in a straight line, it is known as perfectly negatively correlated, okay. So if it is like, if there is two dotted lines, if it is not perfectly correlated, then it is highly correlated, okay. So that will be a figure like that, and then in case of negative correlation, it will be like that, okay. So this is basically scatter diagram, is you just plot it in a graph, okay, on your x and y axis. So that's your scatter diagram, and then what we will look at is Karl Pearson's coefficient of correlation, and then Spearmans rank correlation. So in this Spearmans rank correlation, you will assign rank for every number, and then based on that you will calculate the correlation, okay. So the important thing that we will be looking at, or we will be mostly talking about, is Karl Pearson's coefficient of correlation, okay. So let's look at Karl Pearson's coefficient of correlation, and then we will move on to Spearmans rank correlation. In case of Karl Pearson's correlation coefficient, if two variables, let xy and x2 be a two variable, then Karl Pearson's correlation between x1 and x2 is computed as R1 to R COV, which is covariance between x1 comma x2, and then after that standard deviation of x1, standard deviation of x2, okay, multiplied by standard deviation, right? So where R12 is correlation between x1 and x2, and then standard deviation of x1 is basically denoted by that figure, this thing, and then after that sigma, you could say x1, and then after that the other thing is this one is standard deviation of x2. How much has it deviated from the mean, right? That is your standard deviation, and then um, of x1, x2 is covariance between x1 and x2, right? So you could use different formula for calculating this as well. So mainly the four things that we need to consider is, are we computing it for a height, like a class kind of thing, or is it just a single number? So we need to look at that as well, like we used to do in the earliest statistics, right? So in case of central tendency, we used to do that, right? So in case of direct method, what we will normally do is that we will use this formula, which is R12 is n is your normal number of observations, and then your x1 into x2, summation of x1 into x2, then into summation of x1 into summation of x2, right? So after that, under root number of observation into your x1 square, which could be your the summation of x1 square, okay, summation. At the end of the chart, you will need to add it up, okay? We will look at that as well. That will make you a bit of clear. So this one is a bit different. So it's within bracket. So summation of x1 and then whole square. And then the next thing you do the same thing is for x2, okay? Number of observation into x2 square, summation of x2 square, minus summation of x2 whole square. Okay, so that is for your direct method. So if you are using assume mean method or shortcut method, you will use this formula, which is basically R12 is equals to n into summation of uv minus summation of u dot multiplied by summation of v, right? So in the below as well, see, you can see this formula is pretty much similar to this. So where only the difference is the u is a difference between x1 minus a. A is your assumed mean. Okay, so that is your assumed mean. So v is it is x2 minus b. Okay, b is your assumed mean again. So in case of actual mean method, what you normally do is that you basically you basically use a bit of different formula. So it is summation x1 dot x2. So it's a multiplication of x1 and x2 summation, okay? And then this one is under root summation of x1 whole summation square, and then summation x2 square, okay, under root. So where x1 and x2 is x1 is x1 minus x bar. So what is x bar? So x bar is summation x divided by n, right? That is your x bar. It is a mean, okay? How you normally compute your mean, normal mean, that is what it is. Okay, so x2, same thing. Again, you need to compute your mean for the second column as well. So that you will subtract that figure by that figure. Then you will get your x2, okay? So the derived value is x1 into x2, and then you multiply it first of all by column, and then you add it up, and then you use this formula, okay? So in the standard deviation method, what we normally do is that normally same as you would do with your standard deviation, nothing to talk about within the formula, same as assume mean and this formula. So only thing that we need to be careful about is u dash. What is u dash? X minus a divided by your height or common factor, right? So 5 to 10, 5 is your common factor, right? So what is that in case of the second column? B is for the second column. So you would do x2 minus b divided by k, okay? So in case of so that is your a and b is your assume mean, right? So it's your assumption. So h1 and h and k is your common factor. What's the gap between the class, whether it is 10 to 20 or 5 to 10, whatever. It could be different between the columns as well. So we need to compute that as well. So let's look at the uh, properties of correlation, and then that will give us a bit of idea, and we will move on to problems. So when we are talking about the properties, so the correlation is between always, or the value always lies between -1 and +1. Okay, as you can see in the board as well, it always lies between -1 and 1. Okay, so correlation coefficient is a statistical tool, and then it has no unit. So it has no unit. That's your second property. Your third property is it is symmetric, right? R12 is equals to R21. Okay, so you can write it in any way you want, but they are symmetric. You need to remember that. And then they are independent of change of origin and scale. Okay, so it is independent of the change of origin as well as the scale. So it is coefficient correlation is a geometric mean between two regression coefficient, that is r plus minus bx1 x2 dot bx2 dot x1. Okay, so it is a coefficient of correlation in geometric mean is between two regression coefficient. Okay, so in case of independent variable, so if even though the two variables are not linked, two independent variables such as you could say interest and advertising expenses. So interest advert expense but it could be related to profit or any other variable. Okay, so even though there is no connection between that, there is a connection between this two and this two. Okay, that what it basically means. Even though there is no connection between two variables, but there is a connection with both of them of a third variable. Okay, so that could be the case. So that is your properties. Okay, so properties that we need to remember is -1 to 1, and then no unit. Other is symmetric. Is write it in any way. 1 2 2 1 doesn't matter. Independent of change of origin and scale. And then geometric mean is between the regression coefficient, and then it is uncorrelated. Even though the two variables is uncorrelated, there might be a correlation between the third variable to both of them. Okay, to some degree. So how would you interpret this particular result that you get when you compute something? So if it is closer to 1, what you would say? If it is closer to -1, what you would say? So it basically is that. So if it is -1 and 1, then it is perfectly correlated. But if it is between 0.7 and 0.999, then it is highly positively correlated. Okay, so in case of highly negatively as well, it's just the same thing, -0.99 and then less to -0.7. Okay, until that range it is highly negatively correlated. So in case of when it will be more moderate, it will be 0.5 to 0.69 will be your moderate correlation, -0.69 to 0.5 will be -0.5 will be moderately negatively correlated. Okay, so in case of 0 to 4.99, it will be low correlation. Okay, low positive correlation. So if it is R is 0, then there is no correlation. Okay, so that's how we interpret the numbers that we get out of the computation. Okay, so we will look at the third method, Spearmans Rank method. So let's look at that. That is also another interesting one. So in case of Spearmans Rank method, when will we use it is that if the data cannot be quantified. Okay, so suppose if you're measuring some IQs or if you're measuring the beauty, then what we normally do is that we use this method. Okay, Spearmans rank correlation method because you can't quantify it, right? So how is it done is that basically, first of all, you will need the ranks. Then based on that ranks, you will assign it to individual values, and we will see how much the correlation is there between them. That is known as Spearmans Rank correlation method. Okay. So firstly, if you are given the rank or if you are not given the rank, what we will do is that first of all we will assign the ranks. First of all, whether you could assign it from the highest to the lowest, or you could go from bottom to up, but you will need to assign the ranks first of all. Okay, so always remember that if the rank is not given, assign the ranks and then after that compute it. Okay, so how will we compute it is that, so r1 and r2 are the ranks for x1 and xy and y. Okay, and then the formula that we use is that rs is equals to 1 minus 6 summation d square and n square minus 1. Okay, so what is d? D is r1 minus r2, so it's rank 1 minus rank 2. Okay, so normally we tend to see that d is equals to 0. Okay, so it should be near to 0. Okay, so Spearman's thing is formula is 1 minus 6 into summation d square upon n bracket n square minus 1. Okay, so if the rank is given, if the rank is not given, first of all assign the ranks from top to bottom or from bottom to top and then compute it. So what we will look at is now, let's look at standard error and probable error. So that is also another important thing. After that, we will move on to partial correlation. Okay. When we are computing standard error or probable error, what is it? Is that it is a statistical tool which provides us the significance of correlation coefficient. How significant is it? That is what we obtain from it. Okay. So what is the acceptable error? So standard error is 1 minus r under root n. That is the formula that we use. And then for probable error, what we will use is that 0.6745 into standard error. Okay, so the same formula, 1 minus r divided by n. So what will this give us is that if probable error or r is below the probable error, then r will not be significant. If r is greater than 6 times the probable error, then it is considered as significant. Okay, so the next thing that we will also be using this thing for is that when we are computing the limits, so what is the upper limit, what is the below limit, right? So for upper limit, what we normally do is that r minus p for probable error. Okay, so for lower limit, r plus pe, as you've done this previously as well. So we will just test the significance of the r based on our error percentage, right? So we will determine whether whether the r that we are generating, is it significant or not, and when it will be significant if it is greater than pe times 6. Okay, if r is greater than 6 into pe, it is significant. If it is lower than pe, then, or probable here, then it is not significant. Okay, so what we will do next is that let's look at partial correlation coefficient, and then we will move on to multiple. Okay, so what is partial correlation? So partial correlation is a statistical tool which is used to study relationship between one dependent variable and one independent variable, keeping other variable as constant. Okay, constant. So what if there is two variables, say 1, 2, 3. So what we will do is that we will keep these 3 constant, and how much will the change in 2 increase or decrease, or what is the relationship between these two variables that we will study. Okay, so if this is independent variable, one is your dependent variable. Okay, and other variables we will keep it as constant, right? So suppose if you're talking about height and weight, right? So that might be affected by the age as well, right? So what we will do is that we will keep is, which is third variable, as constant, and then we will basically change the height, and then we will get our weight, right? So how much will the variations, a unit increase or decrease in one will change the other by how much we will determine that. Okay, so the correlation between, suppose if you are finding out the same thing and then your x1 and x2 keeping x3 as constant, you could do the same thing, you could change the order as well, you could keep second constant, first constant, does not really matter, only the formula needs to be changed. Okay, so if you are keeping third as a constant and then your second as an independent variable, one is a dependent variable, right? So it's a relationship between one dependent and one independent variable, keeping other variables as constant. Okay, so the formula will be R12, see the pattern. So 1 2 will be at the beginning, minus R13, R23, and then under root 1 minus 1 3 square, 1 minus R23 square. So suppose if you are doing it the same way, but you are keeping the second variable as a constant, so how will we do it? Or what we will do is that, let's keep 1 as a constant. Okay, so the formula will be R23.1. Okay, so what we will do is that R23 minus R12 or 21, you can write it anyway. As we told, it is always symmetric. Right, and then R1213. Then under root will be 1 minus R12 square, which is basically just this figure, and multiplied by R13 square. Okay, so just the formula will be changed, whatever, if you are changing the constant or whatever variables you are changing. So if it is changed, so you will change the formula as well. Okay, so coefficient of this is basically R square, right? So 0.7225. So if suppose if your R12.3 is this much, so there is a correlation of how much, 0.85 between first variable and then second variable. Then what we will need to do is that, so if we will square it, first of all you will get your coefficient. So your coefficient over here is 0.7225, which means that 72.25% of the total variance in x1 can be explained by x2. Okay, so 72.25% variance in x1, because once we change this independent variable, it will impact the first variable, right? So suppose if you are doing it in case of crop, right? So if you are assuming that the independent variable is the seed, so you might change the seed, so that will impact the yield of the crop, right? So any change in the independent variable can explain the change in x1, okay, or the yield, change in the yield of the crop. That is what this basically means. Okay, so let's look at multiple uh, correlation. It is basically just similar to this, but what we will do is that we will keep one dependent variable and then the combined effect of two variables on the one variable. We will look at that. So you could even use like 4 variables as well. Okay, but all these things will be 3 and 4 will be your constant. Okay, so that is your secondary subscript as well. We normally tend to say the numbers before the dot is primary subscript, the the numbers after the dot is secondary subscript. So let's look at multiple correlation, and that will give us a bit of clarity. So when we are looking at multiple correlation coefficient, so what is it? It is a combination of, or it is a study of two variables where the combination of two independent variables effect on a a dependent variable is examined. Okay, so let me explain. So if 1 is your dependent variable and 2 and 3 is your independent variable, could be anything. This is sales, this could be your advertising expenses, and then this could be your other interest expenses, right? So what could this variable have on the sales? So I'm sorry, it should not be sales. So it should be something else, you know. So let's say it's price, okay? So how much will this particular independent variable changes will affect our sales, which is dependent variable, right? So that is what is it. So it's like denoted in this way, R1.23. So it's a combined effect of second variable and third variable on first variable, which is a dependent variable, right? So the denotation is a bit different than the partial one, because in partial one we write two numbers earlier and then 3 is the constant, 1 or 2 is your independent and dependent variable, right? So it's between these two, right? So 3 is your constant, okay? So whereas in case of multiple correlation, you are actually studying the effect between, or you are studying the variables, independent variable and dependent variable, but what you're doing is that you are examining the combined effect of 2 and 3 on 1, okay? Or you could change this thing as well, so you could make it 2.13. So how will we write it in formula? So the formula is pretty simple. What we will do is that, so see, 2.13, right? So what we do is that, first of all, we write this two numbers, which is R21, 23, okay? So you can write it in any order. 21, 12, anything, R, okay? So next will be R23 minus 2, R13, 12, R23, okay? So in the minus 2, all the three correlation, okay, between the three variables, okay. After that, what we will do, 1 minus this whatever number is behind the point, which is 1 3, right? So this is how we compute the formula for this, okay. So basically it's what we are trying to examine is that, basically in this particular example, I'll give you an example as well. Suppose x1 is sales, x2 is your advertising expenses, and then x3 is your price, right? So suppose if you get, after you've computed the formula and entered everything, suppose you get R12, 1.23 is equals to this, 1.23 is equals to 0.95, right? So when we use coefficient or when we square it, so in case of coefficient, we always square it, right? So that will give us the variability or explanation of the variability in 1 based on 2 and 3, right? So when we square it, we get 0.925. If expressed in percentage basis, it will be 90.25. So the total variation in X1 or in sales is explained by X2 and X3 by how much percentage? 90 percentage. The rest is associated with, so suppose if this is thing, so if you subtract it by 100, you will get 9.75 percentage. So this is your changes or the variation in sales because of other independent factor, okay, or other independent variable, okay. So that is what basically the coefficient will tell us. So it will basically, what will it tell us? It will tell us that how much variation is caused by the other independent variable in the total change in sales, okay. So that's what it will basically provide us. So the characteristics is normally like it is symmetric, right? So 1 2 2 1, you can change it interchangeably. Normally this figure will be a bit higher than R1 2 or correlation of 1 and 2, okay. So normally that will be higher, and then your values will range from 0 to 1. Okay, so it should be between 0 and 1. So that's pretty much it. So if you look at the problems, you will basically get the idea about it. So next we will look at regression analysis. Let's explain, and then let's first of all find out what are the principles, and then we will move on to the examples. Okay.